continuing on with basic Wi-Fi concepts, we had previously asked these questions, and let's take a look at what you might find in a typical laptop. You might find some kind of helper tool like this, let's say on a Windows operating system, where it's looking around for the access points that it can see, and then it tries to connect. So in this case, well, okay, no, not maybe not that many connections. So it sees one, and the signal strength is pretty strong. That's why you see about 80% here. If there's others that might be further away, then it might also show others. So people typically would then select one of these, and then your laptop Wi-Fi network interface card, or NIC, will then try to connect to that network. So what is happening when it's trying to connect to that network? What does it mean? So this issue about the multiple Wi-Fi networks around, what's actually happening is that in order to show you a GUI like what we saw in the previous slide, the network interface card is actually scanning through different frequencies to find the different Wi-Fi networks around. Now, depending on the capabilities of your network interface card, it might be scanning at 2.4 gigahertz, 5 gigahertz, or maybe both. And it's like tuning to an analog radio station. So you just scan through different frequencies. And what it's listening for is beacon signals that are being transmitted by the access points. So it's going to gather beacons signal information. It's going to then be able to know about the networks that are around. Now, the selection of the network, there can be different ways that it's implemented. So in the example that we saw here, the GUI is letting the user choose, and sometimes it might store the preferences so that the next time you turn on your laptop and try and look for a Wi-Fi network to connect to, it might automatically connect to something that you're previously successfully connected to before. So user might be presented with a choice, or it might try to be smart about it and automatically reconnect with something you had connected before. Now, just seeing these networks doesn't mean that you can connect to them. So after you select a network, there might be some access control that might prevent you from connecting to your selected network. That's where authentication is very important, because remember, this is wireless. So the access point is just receiving some signals over the air. It doesn't really know who you are. It's not like a wired network where there's cables connected to certain devices. So physically, there's this physical connection. So therefore, the network needs to do some kind of authentication. Various schemes are possible, and we'll talk about them. Some are much stronger, some are much weaker than others. In fact, the so-called open authentication is actually not doing any authentication. It's like letting everyone and anyone in. So after authentication, there's another concept about actually getting set up to talk to the access point. You need to associate with the BSS or the ESS, because the access point recognizes that you are authenticated as a particular user, but you still need to associate to the access point to this BSS or ESS. Associating is kind of like actually the analogy in the wired local area network is actually connecting this cable from your laptop or PC or whatever to the switch, and then you're able to physically get the packets to and from the to and from the destination and source. Now, typically, because we're talking about connecting to the internet, then there's another step that needs to happen after that, because in the process of authentication association, this is beneath the IP layer. So these things are happening without reference to a specific IP address. So it's just about at the layer 2 getting things set up. So then let's say you want to get IP packets to and from devices, then something needs to be done, and ARP is the solution, address resolution protocol. ARP we might already know from just wired LANs. It also can and does happen on Wi-Fi networks. So similarly, you need to have this mapping between IP address and MAC address that you transmit to. Now, when we then moved, let's say, to a new access point in the same network, so you're just moving within the ESS, then you can just reassociate. But yeah, because basically an ESS, as far as the IP network is concerned, an ESS looks like one big local area network. So you're not changing your IP address when you're moving around within the same network. You just need to handle things at layer 2 to reassociate with the corresponding new access point. And then once you do that, you're good to continue with communications. And to then tear things down, you disassociate. And there's one more step that was not mentioned here, but you can also de-authenticate. So de-authenticate is like even more separation, because then the AP no longer recognizes you, meaning the station, as authenticated. So you want to get set up again, you have to go from the beginning to authenticate again.